I am back and I'm here to solve another mock AP Calc AB exam. I found this via Google search again. It's by Lucid Education. I have no idea if this was the actual released exam or not. So I'm just going to say that it's a mock exam. I'm not sure. But regardless, this is good practice of just solving problems if you're studying for the AP Calc exam. Or just if you're taking some other calculus course and you happen to be on this video. Hopefully there's some good problems that are helpful for you too. Okay, so let's begin. I'm going to, as usual, solve about half of the multiple choice no calculator portion first in this part of this mini series or whatever you want to call it. Okay, by the way, if you do find this test online on Google or something, the first two answers in the answer key, they have an answer key to the multiple choice. It's wrong for the first two problems, and you'll see clearly why. They just flipped the two probably, but if you follow the key, it's a totally wrong answer. And you can even confirm, since it's a definite integral, that the choice that they gave is totally wrong. It's not even the same. You can even put it in your calculator. All right, anyway, number one. Using substitution, u is 3x minus 2. This integral is equivalent to what? Okay, so we want to make a substitution. Whenever we want to make a substitution, we want to find du, if we have a u already. So du is 3dx, okay? So we worry about limits of integration afterward. We would get 3x minus 2 is u, so it'll be sine of u. What is dx? Dx would be du over 3. Let me even write that over here. Dx is du over 3. So du over 3, I move to the outside of the integral because it's just a constant. So we can move it out. All right. Since it's a definite integral, we have to change the limits of integration also. So we're going to use these two. So when x is 0, we just plug into our definition. U is 0 minus 2, which is negative 2. When x is 3, u is 9 minus 2, which is 7. So our answer is C. Okay, clearly it's not A. It would not be the same if you put it in your calculator. Okay, now next, this is also not right in the key. We have this as y. We want to find dy dx. So you could expand this all out. It's not big task because it's only squared, or you can use the chain rule, which is what I did over here. So chain rule, so we're going to go derivative of, we're going to do the power rule first because this is the composite function. X to the 4th plus 2 is one function, and some other function squared is x squared or something like that is the other function, okay? Anyway, we're going to use the chain rule here. So dy dx is, so power rule first, 2 times x to the 4th plus 2 to the first power, times derivative inside, derivative of x to the 4th is 4x cubed, derivative of 2 is just 0, so we only have 4x cubed there. We can combine this 2 and this 4x cubed, that's ax cubed, x to the 4th plus 2, and that is A. Okay, that's the right answer, not C. This is what the key put. You can even check in Wolfram Alpha to ask you to differentiate this, you get exactly this. All right, had to emphasize very clearly that the key is wrong so that you don't get mixed up. All right, a line through the point 2, negative 2 is tangent to the function f at the point negative 2, 6. What is f prime of negative 2? Okay, so this is saying that this tangent line passes through this point and this point, okay? So to find the slope of the tangent line, we just find the change in y over change in x, right? Because we have 2 points, we can find the slope. Change in y over change in x, that's what I did over here, 6 minus negative 2 over negative 2 minus 2. That's 8 over negative 4, which is negative 2. Slope of the tangent line, that is the derivative, right? So, because they tell us, they tell us that we have these 2 points. So which point is the point that is on f? So let me even sketch some random f. Tangent line, also I'll touch at one point here, but we are given like some other point like over here. So basically we just found a slope, right? Because tangent line is always a straight line, so we can find a slope. That's what we just did. Now we had to pick which point is the point that's on f. They tell us it's this one. So f prime of negative 2 is the slope of the tangent line at this point, right? And we found the slope, so the answer is B. Hopefully that makes sense. I think I went in a convoluted way to explain it, but derivative is slope of the tangent line. So that's what we found, the slope of that tangent line. Okay. Grain is pouring out of an opening in the bottom of a grain silo. Is that how you pronounce it? I don't even know. The rate at which the height h of the grain in the silo is changing with respect to time t. I think I got confused by reading it because the English is not perfect there. Is proportional to the square root of the height, which is following the differential equation describing the situation. So we just have to translate this as an equation. So the rate at which the height of the grain is changing with respect to time, t. Okay, I see what it's trying to say now. Okay. So that is dh dt, which is translating the words into a variable. Rate of change, so as the derivative of, and this is the rate of change of h, so dh dt, with respect to time, it says. dh dt is proportional to the square root of the height. So when it's proportional, directly proportional, if that sounds familiar, that's like kx or something like that. But in this case, we're talking about the height. So it's k times square root of the height, so square root of h. So that's the answer, k square root h. We're just translating this sentence into an equation. Okay. Where is f concave up? Okay, so when it talks about concavity, we should take the second derivative. Okay, so let's get the first derivative first, and then we differentiate that to get the second derivative. First derivative, we need the product rule, first d second plus second d first. First is just x. D second derivative of e to 2x is e to 2x times 2. We need a chain rule. Plus second is e to 2x. Derivative of the first derivative of x is just 1. So I didn't write that. Okay, so you could just leave it like this and differentiate f double prime, but I thought it would be easier if I factored out this e to 2x from both terms. Okay, so over here, I just move this 2 out over here and wrote as 2x e to 2x plus e to 2x. Okay, so I factored out this e to 2x from both terms. So I got this. Okay, I thought this would be easier to differentiate. All right, so f double prime, we differentiate this. So we need product rule again. First d second plus second d first. First, d second derivative of this guy is just 2 plus second d first derivative of e to 2x is e to 2x times 2. Okay, so again, I factor out e to 2x from both these guys. So that's here. We have a 2 left here. And then I distribute this 2. So it'll be 4x plus 2 is also there. So this simplifies to 4x plus 4. And we can pull out a 4. So it'll be 4 e to 2x times x plus 1. We set it equal to 0 to find our critical points. So our critical point is x is negative 1. That's the only solution here, because e never touches 0, right? So we do our second derivative test. We plug in a huge negative number. This would for sure be negative. Plug in a huge positive number. This would for sure be positive. Okay, so concave up is 1. The second derivative is positive, so it's when x is greater than negative 1. Shown here is f, at which value of x is f continuous but not differentiable. Okay, so at which point is f continuous? Here it looks continuous, right? It's filled, continuous. Here is not continuous because limit from the left does not equal limit from the right. Okay, so let me even write down the definition of continuity. If you remember, limit as x approaches to some, say p, f of x is f of p. This is continuity. Okay, so let's go back to A. That clearly is true here. Limit from the left and limit from the right is the same. This limit exists and is f of p, right? And the same thing for here. Here, to find this limit, we need to take the limit from the left and the limit from the right. They are not the same. Limit does not exist, so it cannot be continuous. Okay, so we can eliminate c because it needs to be continuous. D is continuous because limit from the left equals limit from the right. And the value is the limit, so it's continuous there. So let's move on. Here it is not continuous because limit would be this value, but the f of e would be this value up here. Okay, so the definition of continuity is not met because this side is not equal to this side. Once again, the limit would equal to this value of this whole, but the function's value is actually here because it's filled in there. Okay, so definition of continuity is not met. Now, where is it not differentiable? So if you remember, there's like 3 cases where it's not differentiable. 1 is if it's not continuous. 2 is if there's like a vertical tangent, because that would be an infinite slope. And the other case is if there's like a sharp turn or a corner, because if you think slope of the tangent line, the slope as you come in from the left is some positive slope. But if you come in from the right, remember derivative is limit. So that's why we're looking from both sides. The slope, if you come in from this side, is a negative number. So the derivative from the left and from the right are not the same, so it's not differentiable there. So it's D. Well, over here, slope of tangent line, that's clearly 0 there, and here it's some positive number. Okay. That's how we do that. Okay. Table shows values of f prime. Although f prime is continuous over all real numbers, only selected values of f prime are shown. If f prime has exactly 2 real zeros, then f is increasing over which of the following intervals? Okay, so what's the relationship between f prime and f if f is increasing? It's critical to remember when f is increasing, the derivative is positive. Okay, so why does it say if f prime has exactly 2 real zeros? So the 2 zeros are here. So it just tells us that afterward it'll keep increasing over here, it looks like, right? Because from here to here it's increasing. So afterward it'll keep increasing and will not ever decrease again. And be a 0. Basically, that's what it's saying. And over here, if we go this way, but yeah, coming from negative infinity to 0, it'll be decreasing also. Okay? It'll be decreasing, not also, it'll be decreasing and it won't have another 0. Okay? It'll be some positive, probably like up to positive infinity is decreasing, something like that. Okay? That's what this is saying. Okay? So the key point here, once again, is f increases, the derivative is positive. So this are just values of derivatives. So we know that between 1 and 5, f is decreasing because the derivative is negative. Okay? So over here, the derivative is positive, so f is increasing. Over here, again, derivative is positive, f is increasing. So the answer is B. Okay? Here, we just want to find the derivative of this. Product rule, not hard. First d second plus second d first. The first, x cubed. The second derivative of sine 3x is cosine 3x times 3 by the chain rule. Plus second, the first derivative of x cubed is 3x squared. And then we just simplify. I see that we can factor out 3x squared from both terms. So if we do that, over here, we still have one factor of x left because it's x cubed. So it's x cosine 3x plus sine of 3x. Okay, so that looks like choice E. Okay, let's move on. At each point xy on the graph of function f, the graph has a slope equal to 4x minus 4. If the graph of f goes to the point 2, 3, then f is equal to what? Okay, so the slope of the graph, hopefully that sounds familiar, that's the derivative. Okay, because remember slope of the tangent line is derivative. All right, when instantaneous rate of change f prime of f. Okay, so I wrote f prime is 4x minus 4. Okay, now we want to solve for f, and they give us the initial condition. That's why we're going to find the particular solution of this differential equation, kind of. Okay, so to find f, we just find the antiderivative, integrate both sides. So f is 2x squared minus 4x plus c. We just use the power rule. Okay, now we're going to use the initial condition to find our c. So f of 2 is 3, they tell us. Okay, so we just plug in 2 as x. So into here. So 2 times 2 squared, which is 4, minus 4 times 2 plus c. We solve for c. What do we get? So this is 8 minus 8, which is 0, right? So c is equal to 3. So f of x is just, we plug in c back into here to find our particular solution. This is our general solution. Now our particular solution is 2x squared minus 4x plus 3. The derivative of a function g is given by this guy. When is g increasing? So we want to find when g prime is greater than 0, because like in the other problem, when the function increases, the derivative is positive. Okay? So we're going to do the first derivative test, basically. So we want to set g prime equal to 0. So we want to set this equal to 0. So what did I do over here? Well, I want to make this into one fraction. Okay, so I multiply this x by x squared divided by x squared. Oops, sorry, this should be x squared there, right? Because x cubed over x squared is x. All right, so same denominator, I can combine the fractions. 4 minus x cubed over x squared is equal to 0, okay? So we solve for x. What matters is the numerator. Okay, so we want 4 minus x cubed equal to 0, or x is cube root of 4. So our critical points are cube root of 4, but also we want to put 0 because our critical points are also when it's undefined. So it's undefined as 0. Hopefully you can see that because it will be divided by 0. So those are our critical points. Now we do our first derivative test. So I just draw my usual number line with our critical points. We plug in a huge negative number, so something in this interval, into here. Okay, a huge negative number. Okay, so 4 minus some huge negative number cubed. Okay, so let's ignore the 4 first. So what's a huge negative number cubed? That would be negative, right? I'm asking about the sign. The sign of a huge negative number cubed is negative, but we have another negative here, so it'll become positive, all right? And then a huge negative number squared is positive, so the sign is positive. Okay, you plug in some number between 0 and cube root 4, like 1, for example. If you don't know that, you can plug in 1. What's cube root of 4? Obviously, cube root of 4 is bigger than cube root of 1. Hopefully, you can see that. Hopefully, you even know how the cube root kind of looks. Looks very similar to square root, actually. Except that there'll be negative values also, but anyway. Yeah, cube root of 4 is bigger than cube root of 1. Cube root of 1 is 1, so that 1 is within this interval. Okay, so we plug in 1 into here. What's the sign? It'll be 4 minus 1 over 1. That's positive, clearly. And then we plug in a huge positive number. Okay, so it'll be 4 minus huge positive number cubed. So that would be negative on top. Huge positive number squared is positive, so the sign is negative. When is g increasing? Well, that is when the derivative is positive, so it's from negative infinity to cube root 4. Okay, that's how we do that. I feel like the camera is not completely in focus. Let me adjust it a bit. There we go, that looks a little better. I apologize if it was not very clear on the camera for the previous problems. Okay, function f is defined as this piecewise guy. Which of the following statements is true? Is f continuous at x is 2? Does this limit exist? Is f differentiable? Okay, so this is a very typical problem. Okay, so it might help us to find the second one first because the definition of continuity requires this limit to exist. Okay, so yeah, I did it over here. So let's find if this limit exists. So since it's piecewise, we have to find the limit from the left and from the right. So the limit from the left would be, we use this branch, so it'll be negative 2 plus 5, which is 3. And the limit from the right would be, we use this branch, so it'll be negative half times 2 plus 4, which is 3. Okay, limit from the left equals limit from the right, limit exists, so 2 is good. Okay, now let's go back to definition of continuity. Or number 1, if it's continuous. Remember, the definition of continuity is if limit as x approaches 2, f of x is equal to f of 2. Is this true? Well, what is f of 2? It's on this branch, right? Because this is less than or equal to. So it's 3. The limit equals f of 2. So it's continuous. We're good there. Now, is it differentiable? Remember, derivative is limit. So we can find a derivative from the left and from the right also. So I didn't write the whole limit notation of the derivative. So I just wrote derivative left-hand side. So if we differentiate this is the left-hand side, what's the derivative of negative x plus 5? It's just negative 1. We evaluate at our point of interest. That's negative 1. It's just a constant, right? And from the right-hand side, it'll be, derivative of this is negative half. Right? So we again evaluate at our point of interest. X is 2. It's a constant, so it's negative half. We see that the derivatives from the two sides are not the same, so derivative does not exist. Okay, so it's 1 and 2 only. Okay, we have this integral. This should be very easy, hopefully, for you. You can even do the substitution in your head. If not, you can let u be negative 3x. du would be negative 3 dx, and then you need to change your limits of integration and all that. All right, hopefully you could just do the antiderivative in your head. This is quite easy. So it's just e to negative 3x divided by negative 3. You can always check by differentiating this. Do we get back e to negative 3x, which we do. Okay, so the antiderivative of e to negative 3x is this guy, once again. We evaluate it from 0 to 2. That's our original limits, right? So that would be negative 1/3 times e to the minus 6 minus e to 0. And then just do some simplification. You get 1/3 minus e to negative 6 over 3, which is choice C. Okay, and are we about halfway? I think maybe let me finish this page and then I'll call it apart. Shown is a graph of f double prime, the second derivative of f. Curve is given by the equation f double prime is x minus a squared, x minus d. The graph of f has a point of inflection at which values of x. Point of inflection, that's when the second derivative changes sign. So I don't even know why they tell you all about this, but you could just look at this graph. So as I just said, point of inflection is when second derivative changes sign. Where does the second derivative change sign? That's only here at d. So d only. So I really don't know why they tell you this when they give you this graph already. Okay, well, technically you could figure it out that a is not a point of inflection from this equation, but since they give you the graph, you can just easily see it. Okay, last one for this part. Function f is defined such that for x greater than or equal to 0, the line y equals 3 is a horizontal asymptote. Which of the following must be true? Okay, so if it's a horizontal asymptote, then hopefully you remember the limit notation. Limit as x approaches infinity, or even negative infinity, but let's do infinity first, is 3, because it's an asymptote. As x gets bigger and bigger, it will eventually approach, it'll get close to 3, but so when we take the limit, it'll approach 3. And similarly, since it didn't explicitly say, then from as x approaches negative infinity, it should also be 3. So by that, C is correct, but there is all of the above or none of the above. So actually, we can eliminate none of the above. We have to see if all of the above is true. This must be true, by the way. F of 3 is undefined. We don't have any information about the domains except that it's defined for, it's defined for all x greater than or equal to 0. So f of 3 is defined. This is contradicting what they gave us. Cross that out, and we can cross all of the above because A was not correct, so has to be C. We don't even have to check B after that. But I could check B right here. F of x is not equal to 3 for all x greater than or equal to 0. That's not true. It just says that f approaches 3 as x goes to infinity, or x goes to negative infinity, approaches 3. We're only interested in, so we didn't even need this, by the way, because we're only interested in x greater than or equal to 0. But if this is the asymptote, the function can do this. Something like that. So you could cross 3. That's fine. It's just that it approaches 3 as x gets bigger and bigger. Okay, so B is not necessarily true. So the answer is C. Okay, so I'm going to call it apart here. Please like this video if you found it helpful, and also please subscribe if you haven't already. And I'll see you in the next part. Bye.